Okay, guys, hope you're doing all right. Today we're going to start a new chapter, chapter 10, area of parallelograms and triangles is what we're looking at today. I know there's an area of a rectangle up here as well. Remember, a rectangle is a type of parallelogram, so it's about the same. Now look, I know that you probably already know these area formulas, but we're going to do the more challenging versions of these. So I do want you to watch this video, even if you think you know what's going on. Watch the video anyway, because we're going to incorporate trigonometry. We're going to incorporate the Pythagorean theorem. We're going to incorporate special right triangles in what we're doing. Formulas. We are specifically, I don't want to see you write out the area of a rectangle is length times width anymore. That's because all of the formulas we get are going to be based on the basic concept of the area of a rectangle, okay? And so when we look at the area of a rectangle, I want you to say that the area of a rectangle is going to be base times height. Base times height. Now, there's something important to note about height. Height is sometimes also referred to as altitude, okay? And what altitude actually means is from that base, how tall is it at a 90-degree angle, okay? So it's important that it's a 90-degree angle. The reason that that's important is when you start to look at parallelograms and triangles, if you notice down here on this parallelogram, we've got a length over here, and we've also got a length that's straight up and down. We want to use the length that's straight up and down. It doesn't matter what the length of the side of this parallelogram is. I want to know the height. The height is going to be at 90 degrees. One thing that's interesting about a parallelogram is if you imagine if we had a pair of scissors and I could cut this triangle off right here and slide that triangle over, it would actually fit in right here. And what would we have? What shape would we have if I did that? Well, we would have just a rectangle. So the formula for a parallelogram is actually exactly the same as the formula for a rectangle. It's just the base times the height. But you have to be careful, and this is where a lot of guys, even in an honors class, are going to miss this, because the height is always straight up and down. It's always that 90 degrees. Sometimes it's written like this. Sometimes they put arrows out like this, but it's never written like a 4 on the side. 4 would be the length of this side, which is not the height. Okay, so we're going to look at what happens when we are given those dimensions, and we have to work around that to find the actual height of a parallelogram. The area of a triangle, I think you guys already know this, but we'll write it down anyway. The area of a triangle is going to be 1/2 times the base times the height. So rectangles and parallelograms, base times height, triangle 1/2 base times height. And the reason for that is if I took that triangle and I copied and pasted it and flipped it around, what you would have is you would basically have, if I took two of those triangles and put them together, you would have a parallelogram. So a triangle is going to be half the formula of a parallelogram. Okay, so let's look at some examples. Very basic examples. For this first one, this is very easy. We know that this is a parallelogram, and so the area is just going to be base times height. Sometimes when you get some more complicated ones, it's better to actually write out the formula so you know what you're filling in. The base here is 5. That's pretty obvious. The question you have to ask yourself is, which of these is the height? Is the height 4 or is the height 4.5? And based on everything I told you, the height should be 4. So the answer here is 5 times 4, which is 20. But units are important now. And for area, units are square units, right? We're trying to figure out how many square units would fit on that two-dimensional shape. So that right there should be a 2, because this is a two-dimensional measurement. Area is a two-dimensional measurement, so the answer here is 20 inches squared. Look at the next one. Okay, parallelogram. Great. That's just going to be base times height. The base of this is just 2. Now look, I understand that there's all this space over here, but that's irrelevant. That's not the actual base of the parallelogram. The actual base of the parallelogram is 2. The next question is, how tall is a parallelogram? In other words, what is its height off the ground? Is it 4.6 or is it 3.5? In this case, at a right angle, 90 degrees, its height would be 3.5. So our total area for this shape is going to be 7 square centimeters, or 7 centimeters squared. Now, all that you probably got before. Guys, we're going to mix it up now. Okay, we're going to mix it up. Here's an example using some special right triangles, and there's other examples of this as well. But the area of this parallelogram is still going to be base times height. The base is 13. That's pretty straightforward. The question is, what is the height? What is this right here? The height is not 8 times the square root of 2. It is not. And what you'll notice for this particular example is kind of crafty. That's a 45, 45, 90 triangle. And if you guys remember, if that's x and that's x, then this would be x times the square root of 2. So that would mean that this would be 8, and also that would be 8 using those shortcuts. So I can say the height is 8, not 8 times the square root of 2. So now when I do that in my calculator, 8 times 13, or you could even do it in your head, you're going to get 104 centimeters squared. Okay, now let's look at an example with trig. Once again, we got a parallelogram here. The area of this parallelogram is going to be the base times the height. The base is 8 feet, but the height is not 6, guys. The height is not 6. The height is going to be coming down a 90-degree angle. They don't give us that. Here's what they do tell us, though. This is kind of interesting. They give us that this big angle in the corner is 110, and because I know the nature of a parallelogram, that would mean that that is 70 degrees. Well, look at what I have here just in this little corner. I have a triangle where this is 70 and this is 6, and I really want to figure out what the height is. Well, in order to do that, I'm going to use trig. Relative to this angle, I've got opposite, I've got hypotenuse, and so I can say then that the sine of my angle, 70 degrees, is going to equal the height over the hypotenuse, which is 6. To get height by itself, I'll multiply both sides by 6, and so the height actually equals 6 times the sine of 70. That, guys, is what we have to transfer over to here. So it'll be 8 times 6 times the sine of 70. That's what you'll put in your calculator. Make sure you're in degree mode. And if you're in degree mode and you put that in your calculator, what you're going to end up getting is 45.105. So 45.105 square feet. Okay, we come down to the bottom one here. What you guys will notice is this is a very similar scenario. This is just going to be area equals base times height. The base is 12. That's real easy. The height, however, is unknown. It's missing. In order to find that height, they don't give me an angle, so I can't use trig like I did before. But they do give me 2 sides of a right triangle, and so I could say 5 squared plus h squared equals 8 squared, or 25 plus h squared equals 64. H squared equals 39. H equals the square root of 39. Don't put that in your calculator yet. We are going to put that in, but let's just wait till the last step to put that in so our answer is exact and unrounded. So if I now put in my calculator 12 times the square root of 39, I will get 74.94 square centimeters. Okay, last half of the lesson today, guys. We're going to find the area of a triangle. The area of a triangle is 1/2 times base times height. This is why I sometimes encourage you guys to write down the formula. I want to see this formula on your homework. Don't just give me the final answer you put in your calculator. I want to see your work written out. In this case, the base is 1 foot. Okay, so I bet a lot of you guys did 5 times 1 and divided by 2, and you said 2.5. We got different units here. So it's a little bit tricky. How many inches is 1 foot? 12 inches. So we got to make sure we're always in the same units. So 1/2, the base is 12, the height is 5. And so when I do this work, sorry about my 5 there. When I do this work, 12 times 5 is 60, and half of that is 30. But what are my units? Well, I was working in inches, so I say 30 square inches. We'll look at how to convert that to square feet on a different video. Okay, guys, so I'm looking now at this next one. This is an isosceles triangle, so this is a different situation. The area of a triangle is just going to be 1/2 its base, which in this case is 8, times its height. Its height is not 12. 12 is not straight up and down. That is what the height is. So because this is isosceles, when I draw that in, I bisect this exactly, and this would be 4 centimeters here. And so I get 4 centimeters squared plus h squared equals 12 squared, or 16 plus h squared equals 144. 144 minus 16 is 128, so h squared equals 128. H equals the square root of 128. Just put that in there exactly, and now on your calculator, you can put this in your calculator to get the final answer, and that would be 45.25. 45.25 square centimeters. Okay, guys, one last example. Again, this is the area of a triangle. The area of a triangle, I'm going to write down the formula. 1/2 times base times height. The base is 20. The height, however, is missing. I don't have the height. I don't have that distance that is straight up and down. What I do have, though, is if I look at this portion of the triangle, is I do have a right triangle where I have 2 of the 3 unknowns. So there's a right triangle. I'm looking for h. I'm given 40. And this is 18. So I'm going to use trig here to solve this. Relative to this angle, this is opposite. This is the hypotenuse. That's going to be the sine. So I can say the sine of 40 degrees equals the opposite, which is my height, over my hypotenuse, which is 18. Multiply both sides by 18. So height equals 18 times the sine of 40. That's what I put in for height. 18 times the sine of 40. Just to show you that real quick, if I just do that on its own, that height right there is 11.57, okay? But I don't want to round that until the very last step, so then I multiply that times 20 times 1/2, and then I'm getting 115.702 square inches. You could round to 2 decimals there if you want. I just did 3. Hope this helps, guys. Do the homework, upload it, and most important thing, be sure to check the schedule for live chats tomorrow and Thursday. We got to get that in, and that will be a scored assessment. So part of your work the next 2 days is to check in with me and talk to me on according to the schedule on that is posted. Thanks, and have a great day.